Hello. Today we'll be discussing the composition of a function. The composition of a function is defined as a function whose values are found from two given functions by applying one function to an independent variable and then applying the second function to the result, and whose domain consists of those values of the independent variable for which the result yielded by the first function lies in the domain of the second. Now what this is just basically telling you is that you'll be placing one function inside of another. This diagram will explain what I'm kind of saying. The input f will be combined with x, giving an end result of f of x. The next step in this process will be inputting g, combining it with f of x, giving us the end result g of f of x, which basically means if you were to have g of x in a formula, the x value would be whatever f of x is equal to. And I'll explain in my example what this means. Now this version is just having g first, so the input g will be combined with x first, giving us gx, and the next step is combining f, the input f, with g of x, and with the net result of f of g of x. Now here we're about to go into the math. So here we have two different equations. The first is f of x plus 2x is equal to 2x plus 3. And the second equation is g of x is equal to negative x squared plus 5. Now they're asking us to find the f composition of g of x. Now that little symbol represents composition, so the f composition of g. Okay, so if we were to go back to our diagram, if we were to look down here, f composition of g, the equation we'll end up using is f of g of x. So we will be placing here, we will be writing f of g of x. So what that will mean is f, so what's the value of g of x? It would be f of negative x squared plus 5. So once we get to this, the basic equation of f of x is 2x. So that, since this is the value of x, we start a parentheses, and x will be replaced with negative x squared plus 5, close parentheses, plus 3. Now we distribute the 2 to the equation that's inside of the parentheses. So f of negative x squared plus 5 is equal to 2 times negative x squared is equal to negative 2x squared. Distribute the 2 and the 5, which should give us plus 10 plus 3. Now we combine like terms, and after we combine the like terms, f of negative x squared plus 5 will give us negative 2x squared plus 13. And that would be our final answer. Now, in the second version, I'll be using the same equations. F of x is equal to 2x plus 3, and g of x is equal to negative x squared plus 5, exactly like the other one. But in this one, we'll be finding the g composition of f of x. Now, if we were to go back to our original diagrams, we'll be g composition of x, we'll end up using g of f of x. So we'll take our marker here. We'll end up using g of f of x. So in this version, g f of x is equal to 2x plus 3. So we plug in that for the value of x. So negative, open parentheses, 2x plus 3 squared plus 5. Now, don't forget, you don't distribute the square to this. Remember, you have to FOIL it. So g of 2x plus 3 is equal to negative 2x plus 3 times 2x plus 3 plus 5. So g of 2x plus 3 will equal to negative, start multiplying, so it's 4x squared, so this is plus 6x, the next one is plus 6x, so it's plus 12x, and then multiply these, which is plus 9 plus 5. So g of 2x plus 3. Now we distribute the negative into the equation. So negative 4x squared minus 12x minus 9 plus 5. Now g of 2x plus 3, once we combine the like terms, is equal to negative 4x squared minus 12x minus 4, and that's our final answer. And that's just one of the examples. But now we're going to go into a real life application. Now, for the equations that I'm about to show you, C is going to equal the cost, X is going to equal the number of units, and T is going to equal time in hours. Oh, forgot to see. There we go. So in this equation, C of X is equal to 45x plus 500. So the cost is equal to 45 times the number of units plus 500. So and then the next equation, X of T, which is basically talking about the units, means that in T amount of hours, you'll produce 9 units. So, in the equation here, C, composition of X of T, they want to find how much it would cost for an X amount, for a T amount of time. Because at the end, that's all that really matters in a business. Is how much they're gonna spend, how much they're gonna make. So just think of this problem as a business planning how much they're about to spend on a product. So C of X of T is basically asking for C of X of T. So C X of T is valued at 90. So we go to our equation and we get 45 times 9t plus 500. So C of 90 will equal 405t. Once the 45 and the 9 are multiplied, will equal 405t plus 500. So what this equation is saying, that at any time given will be multiplied by 405 and then add an additional 500, and that will be the end cost of producing a product. And that's it.